Okay, so today's notes are on equations, and our content objective is to both solve equations and write them. Our language objective is to use the correct terminology to describe and explain equations and how to solve them. So we're going to jump right in with an example that's pretty straightforward. I want us to solve for y. In the given equation, we have negative 27 plus 6y equals 3 parentheses y minus 3. So our first step here, we're going to distribute. So I have negative 27 plus 6y equals 3 parentheses y minus 3. We distribute in the 3 and we have negative 27 plus 6y equals 3y minus 9. Now our goal is to get all of the variable we're solving for on one side. So move all y's to one side. As you probably know, there's more than one way to solve an equation. I'm choosing to move the 3y so that I have a positive 3 on this side, but you could move the 6y over there. You should end up with the same values no matter which way you do this. It just would look different as you solve out. So now I have negative 27 plus 3y equals negative 9. I'm going to isolate y. So now that I've moved y or gotten all the y's on one side, so my only y is over here, or my only y values are right here, I'm going to isolate y, which is then going to require that I add 27 to both sides. So then I end up with 3y equals 18. And then I'm going to divide by 3. And I will end up with y equals 6. If you are in the good habit of checking your answers, you should do that. For the sake of time, I'm going to skip that step. Also, for the sake of time, I'm going to skip our quick check, but we'll go over another example, a straightforward example like this in class. But that's the more or less basic steps to solving a algebraic equation. You're going to get rid of parentheses, move all the variable to one side, and then isolate the variable. So literal equations, you do the same process, but instead of having other numbers surrounding it, you're going to have other variables. So literal equation use at least 2 different variables or letters as variables. So instead of here, we only had y as our variable. Now, literal equations, we're going to do the same sort of thing, but we're going to have more than one variable. So an example, I'm going to skip the writing around this and say Celsius or C equals 5/9 times parentheses F minus 32. And I want us to solve for F. So there are 2 variables, C and F. This equation actually represents the temperatures in degrees Fahrenheit or Celsius in terms of Fahrenheit. So it's a conversion rate from degrees Fahrenheit into degrees Celsius. And now we want to go the other way. So we want to have Fahrenheit in terms of Celsius or F in terms of C. So first step we're going to do, or first thing I want to note, our goal is to isolate, sorry, that's messy, that says isolate F. So our goal is to get F by itself. So our first step is going to be to move 5/9, because I have C equals 5/9 parentheses F minus 32. I don't want to distribute that fraction in because 5/9 and 32, that's not going to give me the pretty number I would like. So instead I'm going to move 5/9. The most efficient way to do that is going to be to multiply by 9/5. So I'm going to give us 2 options because one I think makes more conceptual sense to people, but one is more efficient. So the more efficient way is to multiply by the reciprocal, so 9/5. So I'm going to multiply both sides by the reciprocal of 9/5. So times 9/5 times 9/5. And here I end up with 9 over 5c equals, since I'm both multiplying and dividing by the 9 value here, that cancels. And again, same thing with the 5 value, I'm multiplying and dividing by it. So those undo each other, and I'm left with just f minus 32. The other way, I'm not going to write this one out, but you can do this in 2 steps where you multiply by 9 and then divide by 5. So it's essentially the same thing as multiplying by 9 over 5, but it does it in 2 steps because then you cancel the 9 and then cancel the 5. If that makes more conceptual sense to you, you're welcome to do it that way as well. So the next thing we're going to do, last thing to get the f by itself, add 32 to both sides. So I have 9 over 5c plus 32 equals f. You can leave it like this if you want. I prefer to write the isolated variable on the left side, since that's the way we read, left to right. So I'm going to write my final answer as f equals 9 over 5c plus 32. Awesome. So that's all we're going to do for that for now. The last thing I want to go over together is distance, rate, and time stuff. So I'm going to flip the page for this so I have enough room. But we're also going to do in this section applications, which are just basically word problems. And I'm going to focus today on ones involving distance, rate, and time. So we're going to do a quick refresher on that. I know you've seen this before. Distance is equal to rate times time, or D equals RT. So if you have forgotten that, or if you've never seen it, distance is equal to rate times time. That's a really useful equation that we can use for a lot of the problems you're going to see. Not all problems we're going to see we'll see in this lesson will involve distance, rate, and time, but several of them will. So our example, I drew that line too soon. Our example, we have 2 skateboarders travel in opposite directions. One travels at 8 feet per second. The other travels at 10 feet per second. How long until they are 2,000 feet apart? Sorry, that got a little messy, but here's what we're going to do. So we know distance is equal to rate times time. So the first thing I'm going to do is set up 2 equations for the distance of each skateboarder. So I'm trying to figure out when they're 2,000 feet apart. So I'm going to first set up one that represents the distance of skateboarder A. So his or her distance would be rate, which is 8 feet per second, times time. So I know 8 feet per second times the time will give me the distance of that first skateboarder has traveled. The second skateboarder is going to be 10 times t, or 10t, because it's 10 feet per second. So 10 feet times however many seconds is how many feet this person has traveled. So I know the total distance traveled is going to be the distance of this skateboarder and plus the distance of this skateboarder, since they're traveling in opposite directions. So since this one's going this way, this one's going this way, the distance total is going to be equal to the distance of the first skateboarder, 8t, plus the distance of the second skateboarder, 10t. So I'm going to add their 2 distances, and that will give me the total distance they are apart. So that's what I did in my second step. I wrote an equation for the total distance. And then I'm going to substitute the distance which we know to be 2,000 feet. So I know 2,000 feet is going to equal 8t plus 10t. And then I'm just going to solve for t. Since I'm asking how long, I know I'm solving for t. So I have 2,000. If you already wrote 18t, that's fine. And then I'm going to divide both sides by 18. And I get that 111.1 repeating is equal to t. So the time is approximately 111 seconds. So that would be our answer, 111 seconds. All right, we'll have more practice with this in class, but make sure you write down any questions, comments, or concerns you have so we can go over them together then.